Alright, so here we've got the output. So I'm going to scroll all the way to the top, and here's an example of where the early stopping threshold was stopped, and so that stopped the building of the tree. Then this next section is the prediction versus the actuals, and then here's a calculation of the mean squared error. So again, the mean squared error. Here, just for this sample, I'm using a subset of the computer data set. And there's the value of the mean squared error. The next section is the ID3 demo. This is a classification problem using the house votes data set. And so here is the information gain being calculated right here, and then the gain ratio. This is being calculated for each loop. Then here you can see the actuals versus the prediction, and because this is a binary outcome, the actuals and predictions are just discrete values of 0 and 1. And here the response variable is whether or not a given congressperson is Democratic based on their vote. So here what we can see is the original tree, and then we start the pruning process. And again, these predictions are just spitting out because of I'm having them demoed. And then here what we see is the error of this new tree is actually higher than what we had previously. So then we'll keep that prune tree. And so finally we end up with the final tree being pretty small with physician fee freeze. If they voted no on that, they're likely Democrat, and if they voted yes on that, they're likely Republican. And the accuracy here is 97%. So then this is all the code that generated this, and I'm going to switch over here now to a demo of some of the outputs. So from that demo I just showed didn't have cross-validation, just for the ease of showing the results. So here's a screenshot of, again, just a subset of a test fold for the computer data set. You can see here there's folds 0, 1, and 2. I chose 3 folds just for computational simplicity for the demo. Then similarly for test fold, we can see the same thing for the house votes data set. Again, folds 0, 1, and 2. Here's the regression tree with early stopping set to 10, and this is the tree that we get here. And we can see that when we take out the early stopping, setting the threshold to 0, so effectively no early stopping, then we get a much longer tree. From classification, we just sort of showed that a little bit, but here we have the result of the pruned tree, and then comparison to the unpruned tree. So again, we've demonstrated the actuals and predictions being made, and then getting the assignment, and then shown the different output values. And so that is my demonstration for this week. Thank you for watching.